Hello, Algebra 1 students, and welcome back to Problem 31. Problem 31 comes to us from Lesson 7.2, if you want to jump back to that video and get a refresher on what we're doing. They're asking which properly describes the graph of the function f of x equals 1/2 x minus 6 squared minus 10. And although you don't have to graph this, I think the graph is going to help me and help us see a nice little visual of what's going on. So I'm going to sketch a quick little xy axis. Notice that I'll need 6 and 10 on here. And where are the 6's and the 10's? Well, we should probably realize that because this is an HK form, we have a vertex of positive 6, negative 10, like so. And so I'm going to need to be able to go 1, 2, 3, 4, 5, 6, and then all the way down to negative 10. 4, 5, 6, 7, 8, 9, 10. Positive 6, negative 10 looks like it's down here. Okay, and then we need to go ahead and graph our a value. As a reminder, this a value is always graphed as being over 1. So that means we're going to go up a half over 1 from here. It's going to be a little tricky because it's pretty small, but that's all right. Up a half over 1. Let's see, over 1 would be about over here. And I have to go one more in this direction, over 1, like so. And so we get a parabola that looks something like that. All right, now what are these questions actually asking us? The graph of the function is compressed vertically or stretched vertically, compressed or stretched. We'll come back to that. By a factor of 1/2, factor of 2, translated to the right 6 units and down 10 units from the parent function. Well, let's actually focus on the last 4 words first, this from the parent function, so we can break down what the heck this problem is actually asking us. We should remember that the parent function of a parabola is the most basic parabola that there is. Our parent function, we'll write this out for you, is the equation y equals x squared. This x squared is technically x minus 0 squared plus 0 with a 1 out front. That's as basic as it gets. It tells us it starts at 0, 0, right? And then I can run those kind of same tick marks up this way, and it's going to go up 1 over 1, up 1 over 1, and look something like that. That is our parent function. They're asking us, how is our new function, the one I did in red, compare to the purple function? Well, if you want to start to the comparison, we should start with the vertex. How would I get from my original vertex to the new one? Well, it looks to me like we had to go right 6 and then down 10. So we want right 6, down 10. So if we start looking at, if we backtrack a little bit here, is my function translated to the right 6 and then down 10? Why, yes it is. It could still be a. Is it translated to the left 6 and down 10? Certainly not. That would be someone who forgot to do the opposite of h. To the left 6, that one's out as well. And to the right 6 and down 10, that one's still good. All right, so now we're down to a and d. The last part asks about being compressed vertically versus stretched vertically. And that can be some confusing terminology here. So I'm going to ignore that terminology, and first we're going to compare the two graphs in terms of their width. On my red graph, I went up a half and over 1, right? Up a half and over 1. Imagine if I had just gone, let's say, up a quarter and then over 1, up a quarter and over 1. That would make my parabola wider, wouldn't it? And that's because the 1/2 or the 1/4 means my graph isn't going up as quickly. In fact, it means my new graph, that red function, is going up half as fast as my normal function over here. So that means that the red function is wider, and I'll try to label it with all sorts of terminology here, right? Wider, which of course makes the purple function steeper, right? That makes the red one less steep. Now, if we look at the terminology used here, they're asking about stretched vertically versus compressed vertically. Stretched vertically would be if I took this purple graph, I grabbed a hold of the end of this graph and I stretched it up. If you pulled it straight up, what's going to end up happening is my graph is going to get skinnier and taller. So a vertical stretch, and what I like to think about here, a vertical stretch, a stretch is when your graph gets skinnier. So the question becomes, if I started with the purple one and ended up with the red one, is the red one skinnier than the purple one? And just even based on my graph here, clearly it is not. So my purple graph did not get stretched vertically. Instead, we say that my red graph is compressed vertically. When you compress something, you push it down. I like to think of that lamp in Pixar. It always jumps on the eye in the Pixar thing, right? It jumps up and down and it smushes it. That's compressing the eye. It's smushing it down. So what you can think of is someone is pushing this parabola downwards, and so it actually forces the parabola to go out wider when you push it down. Okay? And so compressed vertically is really just a fancy way to say that our graph got wider. And our graph will get wider anytime you have a number less than 1 in front of x. Less than 1 means the graph goes up slower, so it is wider. If this number was larger than 1, right, let's say that that number was something like, I don't know, 3 instead of 1/2, well, then my graph would go up 1, 2, 3 over 1, up 1, 2, 3 over 1, and look how my parabola would change. That would be stretched vertically, right? It would be skinnier. But mine was not. Mine is wider, and so we have our correct answer is my graph has been compressed vertically and shifted to the right 6 and down 10 from the parent function. Thank you for tuning in, and I'm excited to continue helping you on your way to success on your Algebra 1 Semester 2 final exam.